Hello, my name is Victor, and this is Group 1.
I'm Matt.
I'm Jenna.
I'm Nelson.
And I'm Josh.
Pause it. This is our simulated AC system.
So for our power supply, we have three 18650s with a battery controller powering our transistor switch, being controlled, sending this information to the Raspberry Pi. Another input we have is this temperature sensor. The Raspberry Pi controls our output, which is the fan, and this is varied by PW.
Here you can see the home page of our AC system app. We use it to interface with the Raspberry Pi. As you can see, the terminal window is currently waiting for an RF comm communication from the app. So now I will hit the connect button, and you'll see the devices start to appear on our screen. We're going to go ahead and search for the ED1 Group 1 Raspberry Pi. Right here, and click on it. And now you'll see the terminal window connected and is currently sending the temp to my phone. So as you can see, our home page has now changed to a connection page, displaying the temp on the temp sensor and giving us options to do. Okay, and now Jenna is going to heat up our temp sensor so that you can see our screen change the temperature. And you can see our temperature currently rising.
The fan we're using is 12 volts and it requires 0.4 amps. When working with the 9-volt batteries, we ran into issues about current, so it would either run slow, and we resolved that by using these 18650s. Each one of these 18650s is 3.7 volts, and they have 5 amp hours. I have 3 of them connected in series, and then they are being powered by this BMS module. The BMS module we have ensures that we have an output of 12 volts and maximum amperage of 10 amps, which is more than enough.
The little thing right here is our temp sensor. And we're using a digital temp sensor that runs on one pin of data and reads the temperature, which controls the speed of the fan while using pulse wave modulation.
Another problem we would run into was keeping the fan off while the Raspberry Pi code was off. So what we did to solve this problem was using this little switch circuit right here. We used an N-channel MOSFET that will keep the voltage on the fan at 0 volts until it receives 3.3 volt input from the Pi.
This is our Raspberry Pi code. So we are using the GPIO sensors on the Raspberry Pi for our inputs and outputs. We are also using the built-in pulse width modulation systems to set our fan speed. So we have a temperature function that will read the incoming temperature, and then through that we have our connecting through Bluetooth. And then that's our disconnect functions, our breaks, to what we have the fan for on and off. And then we have our data cycles. So if the temperature exceeds our 76 mark, it will speed up to our high speed. If it goes below our 75.8 mark, it'll go to our low speed. We left a 0.2 Fahrenheit buffer zone. And then we have our keyboard interrupts.